this is the introduction to Chapter 8. This is a review from Introductory Algebra, so this should all look familiar. We have a rectangular coordinate grid, and we're just going to practice plotting points. So point A is at 4, 7. Remember the origin's in the middle. We'll go 4 to the right and 7 up, and we'll place point A at that ordered pair. So remember the first number is your X, and the second number is your Y. X always tells you to go left or right from the origin, and Y goes up or down. This should all be very familiar. Point B is at negative 4, 7. So we're going to go to the left 4 from the origin, and then up 7. So that's where we're going to have point B. Point C is at positive 4, negative 7. So back to the origin, positive 4 to the right, negative 7 down. It's going to be point C. Point D is going to be at negative 4, negative 7. So back to the origin, negative 4, negative 7 will be point D. So you should be very comfortable plotting points. Remember, the horizontal is the x-axis. The vertical is the y-axis. We have 4 quadrants for the coordinate grid. They kind of go in a strange order. Quadrant 1 is the top right quadrant. We call that Q, Roman numeral 1. That is the positive quadrant. All the x values are positive, all the y values are positive. From quadrant 1, we go backwards to the left. That's Q2, Roman numeral 2, quadrant 2. Here, all the x values are negative and all the y values are positive. So they call that the negative positive quadrant. From quadrant 2, we go down to the bottom left corner. That's quadrant 3, Roman numeral 3. They call that the negative quadrant. All your x values are negative, all your y values are negative. And finally, the last corner is quadrant 4, IV, Roman numeral 4, where all your x values are positive and your y values are negative. So sometimes you'll hear them called positive and negative quadrants based on the x and y values. So point A is in quadrant 1, point B is in quadrant 2, point D is in quadrant 3, and point C is in quadrant 4. Let's continue plotting points. Point E is at 0, 5. So 0 in the x direction means don't move. And 5 in the y direction means up 5. So that would be point E. Point F is at negative 5, 0. So negative 5 in the x direction, 0 in the y direction. Point F. Point G is at 0, negative 5. So 0 in the x direction, negative 5 in the y direction. That would be point G. And point H is at positive 5, 0. So positive 5 in the x direction, 0 in the y direction. That would be point H. Point F and H are on the x-axis. Point H is also on the x-axis. Point E and G are on the y-axis. So they're not actually in a quadrant. They're on the y-axis. So it's nice and simple, just labeling and plotting points, refamiliarizing yourself with the coordinate plane. Remember, the middle is called the origin. That is the point 0, 0. So you always start at the origin and then go right, left, up, or down. Let's continue on just kind of reviewing the basic coordinate grid. So here in example 1, you're given different values. We're trying to see if it's a solution to this equation. So we're given y equals 3x plus 4. We want to know if the point negative 3 for x, 27 for y is a solution. So I'm going to replace y with negative 27. I'm going to replace x with negative 3. And then plus 4. I'm just going to crunch those numbers. So negative 27, that's negative 9 plus 4. We know that's not going to be true, so the answer would be no. We're going to do the same thing here. We're going to plug in 0 for x, 4 for y. We see if 4 equals 3 times 0 plus 4. Oops, did not mean that parentheses there. Sorry about that. Okay, and you can clearly see that that is true. So that point is a solution. So nice and simple. You're given an equation. You want to see if the given coordinate point is a solution. Let's do the same thing for the example 2. We're given 3x minus y equals 12. We want to see if 2, negative 6 is a solution. So 3 times 2 minus negative 6. See if that equals 12. That's going to be 6 minus negative 6 becomes plus 6 equals 12, and that works. So that point is a solution. Here we're going to see if 1, 9 is a solution. So 3 times 1 minus 9, we want to see if that equals 12. 3 minus 9 does not equal 12. So no, that is not a solution. Nice and simple, just practicing plugging in an ordered pair into your given equation to see if it is a solution. All right, let's keep going here. Graph the following by finding at least 3 ordered pairs. This is kind of the most basic way to graph. You can do this with any equation. If you have an equation and you have some values for one of the variables, you can plug those in, figure out the values for the corresponding y variable, and plot those points to create your lines. This is nice and simple. You're given certain x values, so we'll plug in each one. 3 times negative 1 minus y equals 6. We'll do a little bit of algebra here. Trust that you're good at this. Get negative y equals 9. So y equals negative 9. If I plug in 0 for x, it should get negative 6 for y. If I plug in 2 for x, I should get 0 for y. And again, you can just work it out. If I plug in 3 for x, I should get positive 3. I'm just kind of working these out in my head. 9, you move it over, yeah, you should get positive 3. So you can work them each out, solve for your y's. Now you have ordered pairs that you can plot. So we're going to plot negative 1, negative 9. We're going to plot 0, negative 6. We're going to plot 2, 0. And 3, 3. Now these should all line up into a nice straight line. My digital drawing is going to be a little rough here, but these should all line up to a straight line. And connect with if you have a ruler, it'll connect nice and straight. Let's do the same thing for the next example. Went too fast there. I'm going to scroll up a little slower. There we go. So we're going to plug in these x values in for x and solve for y. So we have y equals negative 2 times negative 3 plus 3. That should give you positive 9. If I plug in 0 for x, I should get positive 3 for y. If I plug in 3 for x, I should get negative 3 for y. So again, just plugging in each x value, solving for y. Then we'll plot those points. So we have negative 3, positive 9, we have 0, positive 3, and we have 3, negative 3. If you did this right, all 3 points should make a straight line. Forgive my digital handwriting here. And we should have a nice straight line through those 3 points. So you can be given any type of equation, have some inputs for x, and you can always solve for y. Now let's look at one more like that. Sorry, that scrolls really fast. You can pause this video at any time if you need to go back and see something again. Here we have y equals 1/3 x. So I made sure all my x values can divide by 3. Anytime you're working with a fraction, if you pick your own x values, make sure they can divide by the denominator. That way it makes nice, pretty numbers for y. So if I have y equals 1/3 times negative 6, That's -2. 1/3 times 0 is still 0, and 1/3 times 9 would be 3. So -6, -2, 0, 0, 9, 3. Connect those with a nice straight line, sort of, and you have your linear equation. So nice and basic, plugging in different values for x, solving for y, and graphing. Let's look at some more. Here are some nonlinear, so these are not going to make a straight line. These are called nonlinear equations. We saw linear, all straight lines. Here are some that are not going to make straight lines. So this equation is y equals x squared. So I'm going to square each one of these values. So y equals -3 squared. Now -3 times -3 is +9. -1 squared would be +1. 0 squared is still 0. 2 squared is 4. And 3 squared is 9. So notice you have the same output here twice, so it's not going to make a straight line. So if we plot -3, +9, -1, +1, 0, 0, 2, 4, and 3, 9, makes kind of a V shape, but we're going to connect it more with like a curved U shape. This is called a quadratic equation. You might have seen this before. We'll talk more about quadratics later on in the course. And this shape, you might recognize it as a parabola. You might have heard that word before. Again, we'll learn more about parabolas later on in Chapter 9 and Chapter 12. All right, let's look at the next nonlinear equation. Here we have the absolute value of x. So the absolute value of -3 is +3. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 2 is 2. And the absolute value of 7 is 7. So even when we have negative input, we still get a positive output. So we'll plot these points here to 2 and 7. 7, you're going to connect these with a sharp straight line starting in that top corner of your grid. Kind of straight there. And then straight out that diagonal through the other corner of the grid. This makes a sharp V shape, unlike the quadratic that curves. This is a sharp V shape. This is the absolute value function. We don't learn any more about absolute value in this course, but you will see this in college algebra. So that's the absolute value function. It makes a V-like value. All right, let's look at one more nonlinear. Notice these are not making straight lines. We have y equals the square root of x. So we have y equals the square root of -4. You might already know this or you might not. If you put in the square root of -4 in your calculator, you're going to get an error. You cannot square root negatives. We'll talk about this more in Chapter 11, but this does not work. There is no solution for -4. It just doesn't exist. Well, like I said, we'll talk more about that in Chapter 11. The square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. You cannot square root negative values, so the smallest this graph goes is 0, 0. So it starts at 0, 0, 1, 1, 4, 2, and 9, 3. And it makes kind of half a parabola curve this way. Sorry, I didn't go through that one point. There we go. So it makes kind of half a curve. It's called the square root function. We'll learn more about that. Well, not in this class. It'll be in college algebra. Square root equation. Square roots are really finicky. We talk a little bit about them in Chapter 11, but you'll see this function more, this graph more, in college algebra. All right, I'm going to pause there and make a second